Hello, in my own venture is based in an example found in Tracker the Spring Wars, corresponding the study of two springs. In this lab, we want to compare an experimental data with a model data. We want to study the Newton's second law, the spring mass system, and harmonic oscillate movement, considering the principle of energy. I need to make something clear. In this model is an approximation in the real movement. I am not include the function position described in the underdamped oscillation, like this one. I take the equation used in the previous lab, like Newton's second law, Hooke's law, energy principle, and drag force from the air. And here we are, the physical situation. The spring wars, two springs attach a car with a mover in this kind of situation and this graph situation. The fundamental principle is the Newton's second law. The agent constant is the spring, and the agent acting at distance is the earth. The Hooke's law is this one. In Python code, this is something important things. Spring 1, spring 2 definition, the arrow 1 and arrow 2 black and red. Two constants, two initial longitude of the springs, and two L1 and L2, S1 and S2 as difference of magnitude L1, kinetic energy, potential spring energy. This is initial energy, spring force 1, spring force 2, F net, drag force in this model L1, L2, and this is variation of potential energy, spring energy. This is the graph plot, the arrow scale. At running the simulation, we have this situation. This is the movement of the two springs. This is the graph plot of the position in real data and the experimental data. In this point, the ball is reached the zero position, the equilibrium. The experimental data is the red line and the blue line is the Python code. In my model is not very precisely, and this have this variation in the end part, because I don't include the exponential function and cosine and sine function. This is a little variation of graph plot, the magnitude F magnitude spring 1, magnitude F spring 2, and the result is a continuum graph with this situation. As you can see, the red line and the blue line represent the different force, both in opposite position in the max value and the minimum value in time. Just in this point and this point where the both force is canceling, it definitely force is not zero. And this is not zero because we have a presence of a drag force. The black arrow is the spring 1 Fs and the red arrow is the Fs spring 2. As you can see, this variation of vector in opposite direction of the movement. Now some variation to find the energy plot, and we have the next situation. Here we are. As you can see, the yellow line is the total energy, is not zero like the previous lab. Is a little variation because the total energy is not zero. We have the presence of something element different, like non-conservative force. The delta kinetic energy is the blue line. The delta potential spring energy 2 is the green line, and the red line is another result. The total energy is yellow, is never zero, because we have presence of non-conservative force like drag force. The damping in oscillatory system has the effect of reducing, restricting, or preventing his oscillation, and reduce the frequency amplitude gradually decreasing to zero. In our case, it's an under-damped situation, and this is the initial omega calculated. In summary, we have a beautiful dancing with two springs. More than a spring attack works is a spring dance. When the total energy is not even zero, we have presence of non-conservative force, which makes a work or external agent, and also we have present the thermal energy, which is considering in the drag force. Thanks.